Good afternoon, everyone. I want to welcome you to my class, and I also want to say compliment of the season and Happy New Year to every one of you. Um, I'm going to start today's class with a very brief introduction about myself. I'm going to talk about expectation. Okay, of course, I want to believe you are all for 3021 age, right? Okay. So if you are for 2021 age, so which means you guys are brilliant. Okay, so like I said today, I'm going to talk a little bit about myself, talk about the course expectation. Okay, so let's get started. Okay, so this is me, and of course I'm going to tell you about my degree. I actually that is my name, Kazim Adepoju. I had PhD in mathematical statistics from University of Ibadan, Nigeria. Has anybody heard about Nigeria? Okay, so thank you. So Nigeria is in Africa. So I have a PhD in mathematical statistics. I actually had this in 2016. And of course, I'm a lecturer at the School of Statistics, and I've been in this university for 6 years now. I started my teaching career that same University of Ibadan in 2012. So I'm actually going to say, in terms of experience, I have more than 12 years experience teaching at this level. My area in PhD is robust statistical modeling. And of course, I'm also, apart from being a faculty at the School of Statistics, I'm also an assistant director of undergraduate study. Of course, you can see my office location is at Ford Hall. Of course, this hall, 465. And my office hour is actually going to be 10 to 12 noon every Tuesday. The moment the office hour is conflicting, please let me know. Okay, I'm approachable, I'm flexible. Okay, make sure you feel free with me. Okay, and I'm going to tell you whatever we discuss will be treated with absolute degree of confidentiality. This is what I used to ask for my students for 6 years now in this university. Is there anyone here struggling with the way I talk? Is there anyone struggling with my accent? Okay, I'm good. I'm trying to improve. I was not born in the United States, but I want to try to make sure I'm statistical in talking. Okay, I don't want to talk fast. I don't want to talk slow. Okay, so that is the information about me. Like I said, office hour is every Tuesday, 10 to 12. And in case your schedule is conflicting, you make sure you reach out to me. I want to hear from you from time to time, what makes my work to be why what made my work to be very easy is when I hear back from students. You can send me a message, and if there's anyone maybe along the line, if you're struggling in my class, please let me know. You can send me a message, we can meet, and whatever we discuss will be treated with the absolute degree of confidentiality. And let me also say I award extra credit. If you answer my question correctly in class, you're actually going to earn extra credit. When you answer my question correctly in class, you're going to have extra credit of 1 point. You can be accumulating that, okay? And at the end of the semester, I need you to send me a message about how you want to spend your extra credit. You can spend your extra credit on assignment. You can spend it on midterm. You can spend it on the final, okay? So, and anytime you earn extra credit, make sure you send me a message after the lecture that, okay, answer your question today in class and I had an extra credit. So please let me know from time to time. Okay, so that is about me, let me tell you this. I know statistics or any mathematical related subject maybe may not be attractive to students, because my experience teaching this course in Africa, Europe, and United States, I realized that students have phobia for any mathematical related subject. And do you know why they have phobia? They have phobia for that because of the way the course is being taught. Some teachers, some professors, they teach this course abstractly. I don't like that. What I always do is to relate every mathematical concept, every equation, every notation to real life. Okay, because when I relate that to real life, the student will appreciate what they are learning because they really want to see what they are learning. So what I'm going to be doing in this class, whenever we're dealing with equation, whenever we're dealing with notation, you need to be able to understand what is the meaning of this notation. What does it stand for in real life? My daughter in high school used to ask a question, like for instance, when she was talking, she was discussing with me about system of equation in algebra, and he said, "Oh, this doesn't make sense. What is the meaning of this?" It's okay. You know what? Let X be the price of cookies. My dad's go. I know cookies. And Y be the price of candies. Oh, I know candies. The moment we relate notations, equations, oh my God, you will appreciate what you're learning. Mathematics is the most simplest subject on earth. But it's actually going to look more complicated, more confusing if you are not able to relate. Okay, so that is brief information about me and about what the expectation is going to be in this class. Is there anyone who want to ask question or who need kind of clarification before I go into the topic? Is there anyone? Okay, like I said, I like getting feedback. Make sure anytime I teach a topic, and I need you to rate your understanding of the topic, like from 0 to 100%. Let's say I teach a topic and you don't really understand the topic. I need you to put the percentage of your understanding, even if it is 0. I want to see, even if it's 100. You need to be able to say, I need you to send me that message from time to time. Now, let's say, for instance, you rate your understanding of the topic less than 100%. I need you to put a kind of question, what you need clarification on. And you know what? I'm actually going to reply to your question. Okay, let's get started. When you take a look at this course, we call it probability. And let me tell you this. This is going to be super easy if we really understand why we're doing what we're doing now. Whenever you want to learn a particular topic, I need you to ask yourself 2 questions. Number one, the number one question is, why am I doing this? Okay, that's number one. Give me 1 second. Let me see. So number one question, why is it? I think the markers here need to be filled. Okay, so why am I doing this? Why am I learning this course? What do I stand to gain learning this course? What do the society stand to gain learning this course? That is the first question you need to ask yourself. Number 2, okay, what skills, okay, am I required, okay, to understand, to understand our concepts, okay? So what skills? Do I need mathematical skills? Like, do I need to understand algebra? Do I need to understand calculus? Before I will be able to follow, I'll be able to understand this. Okay, then I'm going to say yes. In this course, you need a knowledge of algebra, you need a knowledge of calculus, because we're going to get to a point that we're going to be applying that. Okay, and I will advise that you revisit your calculus. It's just gonna be a basic, not complicated calculus knowledge that we need in this course. Then why am I doing this? Okay, why are we learning probability? I'm gonna tell you now. You know, we live in a stochastic environment. Okay, so we live in a stochastic environment. I'm going to tell you why we live in a stochastic environment. Different things happens in different days. We got a lot of variations in this world. And let me tell you this, whether we want to argue it from religious angle or from scientific angle, okay, variations is involved. Okay, now at times we're going to be happy, and at times we're going to be sad. Let me tell you this. I'm going to give you my own experience. At times when I go home, oh, sorry, I didn't tell you about my family. I have 5 girls. So my wife and I, we've been busy. The first one is in college. She's doing a clinical at Mayo Clinic. Anybody heard about Mayo Clinic? So she attended Winona State University. So she's in a clinical year. And I have another one in high school. She's in 10th grade. And I have another one in middle school, 7th grade. Then another one in the other two in elementary, 4th and 3rd grade. So to tell you, we've been busy. At times when I go home, my wife is going to be happy, right? Oh, and at times when I go home, my wife is going to be sad. You can see the variation that I talk about. Now, if there is no variations, there is no probability. You know why? Probability thrives in variation. Okay, probability thrives in variation. Imagine a world where everything is the same. Imagine a world where the same things happens in different days. Imagine a world without variation. My wife and I, we were arguing about that kind of word, but the response that I give to my wife, that very word will be so dull. That very word will not be eventful at all. You know, I see unity, I see beauty in diversity. Look at the way you guys are sitting down now. You wear different clothes with different colors. Oh my God, that makes this place so beautiful. Okay, so what I'm trying to say, in essence, is if there is no variations, there's not going to be probability. There's not going to be mathematics, because mathematics, has to do with manipulations. If there's no variations, there's nothing to manipulate. Does that make sense? Now, since we have the understanding, there's going to be variations, because we're not going to, as human being, we're not going to have the same experience. We're not going to have the same salary. We're not going to come from the same countries. We're not going to come from the same country. We're not going to come from the same neighborhood. Because of that, how do we understand how to manage, let me just say, stochastic situations? How do we manage situations that is changing? Then we need a knowledge of probability. And that is the reason why I normally say we live in a stochastic environment. We are in probability space. So if we really want to understand our environment, because the environment is stochastic in nature, because the environment is probabilistic, then we need the knowledge of probability to get going in that environment. And that's why you are here. And let me now tell you, in the outline, and that's why we have it. So we're going to be considering introduction to probability. Now you know why We need to study this course. You know why? You need to acquire probability knowledge because we live in a probabilistic world and understanding of the world. When I say understanding of the environment, what I'm going to say, I want to understand my political environment. I want to understand my economic environment. I want to understand my psychological environment. I want to understand my environment in general. That I need the knowledge of probability because in the environment, there's variations in the environment. Any question? Okay. Now, in the outline, of course, I've talked about course overview. Now I'm going to talk about probability in real life. I think I just mentioned some now, but let me talk about the application of probability in real life. Okay, number one application, marketing. I think I'm going to do something. I like writing. Give me 1 second. Actually, I'm actually going to give you areas of life, okay, where probability. I forgot to mention this. I like recording my lectures and I put them on YouTube. My past lectures, you can also access them on YouTube. Or all you just need to do is put Professor Kazim Adepoju on the YouTube. You're going to see my past lectures. Okay, so I'm going number one, I'm going to talk about marketing. Marketing. You know, why do we need to market our products? It's because there's a variation. Because at times we make sales, at times we don't make sales. That's a variation too, right? So, and what is the probability that our customers, okay, we actually love the products we produce, we supply them. What is the chance that our customers, maybe we are rendering service, okay? What is the probability that they actually are going to rate our service high? Like, look at what I'm doing now. I'm teaching, right? University has a way to evaluate quality teaching. Of course, I think there's a site called Rate My Professor, where students have opportunity, to evaluate the kind of teaching, okay, they are getting. That makes sense because, what makes the system, why I like this part of the world, why I like this part of the world, particularly United States, there's a way they can evaluate your performance. I love that. Okay. So I want to tell you that at times, when you want to talk about teaching, there's some processes, there's some quality that do not conform to standards. Okay, and some conforms to that. That's a variation. Okay, with probability, we'll be able to predict the chance, okay, that customers will be satisfied with our products. That is marketing. Okay, now another one is in traffic engineering. Okay, another one is in traffic engineering. So what I'm trying to explain now, I'm actually here. We are here now. Okay, now another one is traffic engineering. You know, uh, we can use probability knowledge, to track the pattern, traffic pattern. At time before I leave house in the morning, there's so many routes to U of M. I live at Anoka County. Has anybody heard about Anoka County? Okay, Anoka County is about like 40-minute drive to this university. So if I want to come out of my house, I'm actually going to listen to transport news. Okay, so listen to transport because I'm not going to experience I'm not going to have the same experience every day. And that's why I need to listen to news. And let me tell you this, do you know ahead, you know, those who do research in that area can tell what the traffic is going to be tomorrow. Okay, they can actually tell, and that will help us to plan. I don't want to waste my resources. Imagine I just take a route and I realize that there was a very high congestion, then I need to drive back. I can even come late to the I want to prevent that kind of situation. So we use knowledge of probability in traffic engineering. Number 3 is in telecommunications. Okay, in telecommunications. Okay, so how do we predict? You know, if you work with a call center, they normally have like high volumes of calls. And what is the probability that today they're going to have like 1,000 people calling? They need to be able to know that ahead so that they will be able to know whether they need more staff. You understand what I mean? Because let me tell you, in different days, they're going to have different number of callers. Okay, so it is used in telecommunication. The knowledge of probability is used, and that will ensure what I call efficient data transmission. You know, efficient data transmission. Are you sure you are not struggling? See my writing? If there's anyone, you know, let me tell you this. The greatest sin in the whole world. Let me just say one of the greatest sin in the whole world is when one deceive oneself. You know, if I deceive you, right, you're gonna report to me to authority. But what if I deceive myself? Who am I gonna report myself to when I deceive myself? I'm going to live with it forever. So it is not a good idea to deceive oneself. The moment you don't understand, okay, you don't get information that I'm passing across, please let me know. Okay, or you don't see what I'm writing, please let me know. Now, another area where probability is used is in quality assurance. I talk about quality assurance, you know, I talk about quality. You know, a quality means is a measurable characteristics of a product, a service, and a process. Okay, you know, particularly in engineering, where they manufacture. Let's say, for instance, they want to manufacture this. Before they manufacture this, the four of us going to have a target value, right? They're going to have something they sketch, and at the end of the day, when they produce this, they're now going to conduct a test to see whether this conform to what they specify. Okay, now what is the probability? What is the chance that out of maybe 20, we're actually going to have like 3 or more defective item? Okay, because we live in a world where the model we're using is not perfect. You know, let me tell you this. We actually want to understand reality. Reality, okay, reality is probabilistic. When I say reality, I actually mean physical world. The occurrence in the physical world is probabilistic. There's variation. And you know what we want to do? We want to use the probability model to capture reality, but our model cannot give us exact reality. I want you to know that. I'm going to say that again. Our model, our probability model, okay, even though we're using because the behavior of occurrence in the environment is probabilistic, and we're using probability model to capture that, the probability model we're using is not going to give us exact reality. There's always going to be a loss of information that we call error. Okay, loss of information that we call error. But you know what? We acknowledge this in statistics, or what we would just want to do is to minimize information loss. Okay, so if we're able to do that, you know, putting into consideration, minimizing information loss, we are good. Okay, now what I'm trying to talk about here in the quality assurance in the company, we have quality control officer that will use the knowledge of probability, okay, to be, you know, that will be able to tell us what is the chance that what we produce does not conform to a specified standard. Does that make sense? Now, let me also tell you this. We use knowledge of probability is used in criminal justice system. Okay, it's used in criminal justice system. Okay, criminal justice. Okay, Now, let me tell you, in a court of law, let me tell you this. I've seen situation where somebody who commit the offense, let me just say, nature always knows the truth, right? We want to speak the mind of the nature. Nature knows the truth. Let's say nature have it that this guy committed the offense. I've seen situation whereby a court, they charge this guy and accuse it. Courts can make errors. And I've seen situation whereby somebody who did not commit the offense is in jail. Yes, what I mean. So to tell you there's also errors. And don't forget, I told you the other time, we're trying to model reality, but our model cannot give us exact reality. There's going to be error. Or we acknowledge that fact, but we are trying to minimize that. Now, let me tell you this. What is the probability that based on the evidence, this guy is guilty? We can look at that. Okay. And another thing I'm actually gonna say, if nature has it that this guy commit the offense, what is the probability he's gonna be set free? We can also compute that. What is the probability when he commit the offense? What is the probability he's gonna go to jail? We can also compute that. The knowledge of probability is also being used in the court of law. And let me also tell you this. Let's say this guy commits the offense and the court has been able to prove beyond every reasonable doubt that he committed the offense. Before sentencing, the court will consider, they consider some factors that we call aggravating factors. Have anybody heard about aggravating factors in the court of law? Okay, when we say aggravating factors, they will consider what is the probability that this guy is going to commit a crime again. They put a lot of things into consideration before sentencing. There's a difference between when somebody is being found, beyond every reasonable doubt, maybe the person is guilty, okay, then another thing is sentencing. A lot of factors will be put into consideration before sentencing. If the prosecution actually won 15 years, do you know at times they could give this guy 2 years at times, because at times they may consider what we call the probability that reducing the sentence, this guy is not going to commit the offense again. But when they realize that this guy is very, very risky, he's still going to commit the offense, there is possibility it could have a lengthy sentence. Okay, so we use that. But let me tell you this. This has been argued in the court of law, based on ethical ground. They don't really, I know some people that actually going against the use of probability in court of law because that could impact life. Okay, I'm just trying to tell you that. Now, what about in education? Let me see my time. Oh, okay. So what about in education? Education, we use probability. What is the probability that the learning outcome will be met? Okay. Well, can we have a way to compare teaching method? Teaching. Okay, teaching methods. The idea of probability can be used to apply, can be used to compare teaching methods. The fact that you said teaching methods, it means there are different kinds, right? That's variation. Does that make sense? Okay, so with that, we'll be able to evaluate what we call the effectiveness of teaching method. Oh, which teaching method work? The knowledge of probability is going to be used to determine that. Okay, another area is environmental. Okay, in environmental science, the environmental scientists can actually use probability models to predict the occurrence of extreme events. When I say extreme events, I mean the event of flooding, okay, earthquakes, and so on like that. Okay, the knowledge of, at times ahead. At times ahead, they're going to tell you hurricane is coming. They're going to say, oh, they normally alert people of Florida. Oh, it's in Bahamas now. They predict that ahead of time. What makes them to be able to do that? Because they use the knowledge of probability. Okay, so it's just in environmental science. What about in stock analysis? Stock, okay, stock analysis. Okay, what is the probability that a given stock, okay, will actually rise to a particular price within days? We live in a risky environment. We live in a stochastic environment where we expect, what is permanent in life is change. Okay, so there's so many areas that, probability is very, very useful, and that is the reason why we need to study probability. Okay, I've seen some students in the past, when they are studying a particular course, they don't really understand why they are doing that. Because when you are studying a particular topic and you understand the reason why you are learning the topic, then you will appreciate what you are learning. Okay, you can see so many areas now where this is applicable. Now I want to introduce it to probability. Now, we've already talked about the areas now where it is useful. Now I need you to take a look at this. Give me 1 second. Take a look at this guy. People use the time probability many times each day. For example, when somebody is sick and the doctor is going to say, oh, it's 50-50. 50-50 chance means there's a equal probability that the patient is going to make it. Okay, that's too dicey. Now, when you take a look at 50-50 chance of surviving, it's more or less like you have a coin, a balanced coin. How many sides? We have in a balanced coin, 2 sides, right? We got head and tail. When you flip it, okay, any side, the probability of any side showing up is the same. Now, what if another physician said she has 95%, okay, that a patient has a particular disease? Now, let me tell you this. In a stochastic world, there is nobody who have the 100% knowledge of anything. I told you the other time, model is not the same as reality. Model is not the same as reality. And that is the reason if your doctor tell you you have 100% of surviving, then change your doctor. When you have a case, and even though it is so sure, you have a lot of evidence, you understand what I mean? And if your Anthony said you have 100% of winning, change your Anthony. Because even if you have evidence, the judge could be infallible. Anything can happen in in a stochastic environment. And that is the reason why I don't pray at all, to be involved in any litigation. Anything can happen, even if I have my evidence. Okay. Now, and before the doctor can say 50-50, it means the doctor has really compared that situation to 100 similar situation in the past, okay, that particular patient has, and out of the 100, only 50 survived, and that was why I said 50-50. The one of 95, okay, the one of 95% means after I examine this guy, whether there's a disease or not, okay, so the doctor will compare the characteristics of this guy to 100% of the situation in the past. Okay, out of 100%, the number that have that similar characteristics, that have the disease, is 95. That was why I said 95% chance. They don't just arrive at a figure. Does that make sense? Okay, any question? So far, so good, right? Do not hide your feelings. Okay, if you don't understand, tell me. Okay, now I'm going to move right now. Okay, now we want to go into definition. Okay, so how do we define probability? Now we want to start right now. We want to start, using notations. In probability and statistics, we use notation a lot. So I will need you to pay attention to notations. Okay, when we talk about probability, okay, we are actually talking about the ratio of, the favorable outcome to the possibility. Okay, now let me tell you, in a stochastic environment, we have possibility, okay, and out of that possibility, okay, we actually are going to have the occurrence of the favorable outcome. Okay, so the ratio of the numbers of times, okay, the favorable outcome shows up, okay, divided by the number of possibility. That is what we call probability. Okay, take a look at this guy. If M represent the numbers of the favorable outcome, and N, an uppercase N, represent the cardinality of the events in the sample space, I mean the totality, the possible outcome in the sample space, then the probability of event. Take a look at, what this guy is talking about. He's talking about what is the probability of events E. The probability of events E. This very E may be event of success. In a stochastic environment, we have success, we got failure. There are numbers of times successes occur, numbers of times failures occur. And you know what? The N here is the totality of possibility. Okay. And if I want to figure out the probability of events, the probability of that event will mean the ratio of the numbers of favorable events divided by the totality. That's all we mean. Now we want to talk about some definition. Before we can talk about the numbers of events, what led to events? What led to event is an experiment. It is not until you are in your physics lab or chemistry lab or biology lab that you can conduct experiments. Life itself is an experiment. I'm happy that I'm alive. Okay. Some are dead, some are alive, that, everybody in the world, we got different experience. Okay. Now, what led to event is what we call experiment. Okay. I said any planned process of data collection. I'm also going to say, experiments can be defined as any acts that generate outcome. Whatever you do, that will lead to occurrence of an event is an experiment. You are all here now learning, right? Time is coming, you're going to write exam, right? When you write exam, okay, you are experimenting. Then at the end of the day, there's going to be a result, right? And some result could be favorable, some may be unfavorable. But let me tell you this, what do you have in mind? All of us, we want event that is favorable. But you know what? Does that mean unfavorable event doesn't occur? It occurs. But we want to make sure we put every necessary machinery in place for us to be able to secure what we want. Everybody wants something, right? Okay. And, it consists of a number of trials under the same condition. Maybe I'm selling something. I sell on Monday. I sell on Tuesday. I said in different days. I'm selling the same things, but I'm recording different occurrence of events. What do I mean by different occurrence of event? In terms of sales, the sales that I record on Monday is different from what I'm going to record on Tuesday. And let me also tell you, not also in products, even in service, what I'm doing now, this is not the way I was teaching in 2018 when I joined this university. Okay. I remember in 2018, I still have like typical Nigeria accent. Okay. But right now, we keep on improving, right? That is it. Okay. That is variation. If there's no variation, there can never be improvement. What do you want to improve on? If there's no variation gives us opportunity to be able to improve. Does that make sense? Okay. Now, we're still on definition. We want to talk about sample space. By sample space, we mean occurrence of possible outcomes, possibility. Oh, as a businessman or woman, It's either I make profit or loss. What am I going to have in my sample space? I'm actually going to have profit loss in my sample space. Okay, so sample space actually means collection of possibility. Does that make sense? So if you want to understand stochastic environment, if you want to understand our probability environment, then you need to be able to, four of us, have the knowledge of a sample space. The sample space, you need to understand what is a possible outcome. Because if you get a possible outcome wrong, you will get probability wrong. Does that make sense? Okay, so that's what I mean by sample space. Okay, and you know what? In a sample space, we have a simple event. Oh, I'm a businessman. In my sample space, I'm actually going to have profit, event of profit, then event of loss. Okay, so which means profit and loss constitute my sample space. Does that make sense? Now, take a look at this. If I want to give an example now, okay, I want to talk about gender, right? Talk about male, female, okay? In my sample space, this is what I have, okay? Now, I'm going into more definition now. We want to talk about complement. If I have an event A, oh, if my event A is the event of success, what do I mean by the complement of success? Oh, complement of success. That means event that negates success. Which event that negates success? That's a failure. Mathematically speaking, if I define A to be the event I'm interested in, then the complement of that is the event I'm not interested in. Now, the notation for that could be this guy or that guy. Now, if you really want to understand this, I need you to cite an example for yourself, okay, about the complement of an event. Oh, as you are here now, the event of being in my class right now, what is the complement of that? The complement of that is when somebody is somewhere. It's either you are here or you are not. Does that make sense? It's either you make profits or you make loss. Profit is a complement of loss. Loss is a complement of profit. Does that make sense? So that is what we mean by complement of an event. So the event itself is the one we're interested in. The complement of that is the one we're not interested in. Okay, and you know what? The two events, the event you are interested in and the complement, the one you are not interested in, they constitute sample space. Does that make sense? As a businessman, in my sample space, I have event of profit. I also have events of loss in my sample space. That is possibility. And you know what? If I record profit, then the one I did not experience is loss, which means loss is a complement of what I'm experiencing. Does that make sense? Okay. Now we want to go into probability. Okay. The probability associated with the event I'm interested in and the probability associated with the event I'm not interested in. Okay. So the probability of A plus probability of the event I'm not interested in equal to 1. How do I know that? I'm actually going to show you something now. Give me 1 second. Let me see this guy. Okay, let me use this. I'm actually going to draw a Venn diagram that we used. Okay, so let me see. Because when we are talking about sets, we use Venn diagram. Now, if I have this guy now, okay, I'm interested in this guy. It's an event A. Outside this circle is a complement, event that I'm not interested in, right? And the whole thing is the sample space, okay? And you know what? The sample space is going to be, okay, equal A okay, union A complement. What is the meaning of that? Oh my God, this is not making sense to me right now. I want to give it meaning. Okay, mathematically speaking, you know what I'm trying to talk about is trying to tell me in the sample space is either I have event A or I have event that is not A. Union in mathematics means or how. Does that make sense? Or it's either this or that will attract union. Okay, and let me tell you this event and its complement, they are mutually exclusive. What do I mean by mutually exclusive? Okay, so what do I mean by mutually exclusive? You know, when I talk about, I'm going to write that now, mutually exclusive, you know the meaning? Oh my God, mutually exclusive means when A occur, the complement does not occur. Okay, when two events are mutually exclusive, it means the occurrence of this will prevent the occurrence of the other. When I make profit, the occurrence of profit, okay, will prevent the occurrence of failure. Okay, when they are mutually exclusive, we can write it this way. And if you can write it this way, oh, union in mathematics will attract addition rule. If I want to apply probability right now, so if you take a look at the situation, okay, and I said, I introduce probability. Okay, so if I introduce probability to then, if I introduce, if I introduce probability to the sample space, okay, if I want to introduce probability to this, to that, so if I do probability of A union A complement, okay, because of the fact I'm talking about union and the two of them are mutually exclusive, it will attract addition rule in probability. So this guy is going to be probability of A plus the probability of A complement. Okay, the probability of sample space. And when I say sample space, that is 100%, right? Okay, everything. Okay, 100% means 100 over 100. And that's going to be 1. And that was why we got this guy the other time. We got this guy. The probability of A plus probability. Oh my God, my time is I think I have like 4 more minutes. Okay. Any question? So far, so good, right? Okay, thank you so much. Do you know what is going to be my joy? If the least person in this class scored 99% at the end of the day, I will be the happiest professor ever. That's possible. You understand what I mean? So, and you know, you have everybody now has opportunity to ask questions like we're just starting, right? You know, the moment you actually wait for a long time before you ask question because the knowledge of a particular topic is needed in another topic, then the problem will be accumulating. And that is the reason why you got to ask question now if you get stuck. Okay. I'm not going to start this today. I'm going to reserve this till next class where I'm going to talk about views of probability. This is being recorded, like I said, and I'm going to publish this my YouTube tonight. So like I said, you can access my recordings on YouTube. Is there any question today? Okay, make sure you stay safe. Have a very beautiful day. Bye for now, everyone. You're welcome.